let's see what it says, Rolle's theorem. It says, if you have a function that is continuous from A to B, the closed interval from A to B, and f of A equals f of B, also the derivative exists between A and B. I should say the derivative exists instead of continuous, between A and B. I like the word exist instead of continuous. There's a derivative between A and B. I like that better. Then it says there has to be at least one point between A and B, we call it C, where the derivative there is equal to 0. Now again, right now, it's, who cares? What that's telling you, there has to be a point, a min or a max point there. You'll see that in a couple more lectures. The derivative is equal to 0. So Rolle's theorem says a couple of things must happen. One of them, the function has to be continuous from A to B. So this is continuous function. That fits the criteria. F is continuous from this A value to this B value. F of A is equal to F of B. Notice that's the same height. And this function has a derivative from A to B. You don't see any V's in it, no sharp edges, no holes in it. So there's a derivative. Since we met all three criteria, it says it must be at least one value between A and B. Has to be at least one number where the derivative is 0. In this picture, I can see 3 of them. This is one of them, where the derivative is 0. Remember, the derivative is the slope of the tangent line. This is another one, and this is a third one. There has to be at least one point where between A and B where the derivative at that point is 0. Again, this is called what? Max, and min. Now, if my function looks like this, I'll do color cases. This does not fit Rolle's theorem. Why? This is the interval A to B. The function is continuous. There is a derivative for that, but what's the third condition? F of A must equal F of B. Does F of A equals F of B here? No, it doesn't fit Rolle's theorem. So we can't guarantee it's going to be a point between them where the derivative is 0. As a matter of fact, when you look at that picture, there is no point where the derivative is 0. So this is F of A does not equal F of B. So I can't apply that here. I can only apply it here, but can't apply here. I can apply it here. Why? Because F is continuous. 3 things. F prime exists. And the third condition is what? F of A has to equal F of B. If I can satisfy all 3 conditions, I can apply Rolle's theorem. Here, F is continuous. The first condition is good. F prime exists. That's good. But the condition that failed here, F of A does not equal F of B. Therefore, I can't use that theorem. Let's take one, see if we can apply it. Let's take f of x equals x to the fourth minus 2x squared from negative 2 to 2. Let's got you from closed interval negative 2 to 2. Now if I graph that, if you have a graphing calculator, that looks like a W. I don't know why I correct these, because after I correct them, I don't like the way they look. I end up erasing them. If you graph that, it looks something like this. So according to Rolle's theorem, if we can meet all three conditions, there has to be at least one point between the minus 2 and the 2 where the derivative is 0. This is x equals to minus 2. This is x equals to 2. Let's see the first condition. Is f of x continuous? Even if you didn't graph it, I didn't have to graph it. If I looked at this function, is there any point where if I plug it in, there's no answer to it between minus 2 and 2? Can you pick any number where if you plug it in into this equation, you will not have an answer? No. So that condition is good. Condition number 2, let's take the derivative of that. What's the derivative? 4x to what power? 3 minus what? 4x. Is there a point between the minus 2 and the 2 where the derivative does not exist? Is there a value between the minus 2 and 2? If you plug it into the derivative, you will not have an answer. No. So condition number 2 is good. Condition number 3. Is f of negative 2 equals to f of 2? What's f of negative 2? Negative 2 to the fourth power is 16. Minus 8, which is what? 8. What's f of 2? 16 minus 8, which is also 8, right? So that's also good. So since three conditions are good, what they're saying, there has to be, there must be, at least, could be more than one value between the negative 2 and 2 such that the derivative at that point is equal to 0.
Slide your paper over to the right.
I forgot the that, such that there has to be at least one value between minus 2 and 2 where the derivative at that point such that f prime is equal to 0. That's what they're telling me. I want to prove that's true or not. So let me take my derivative and set it equal to 0. Factor the 4x out, what's left? X squared minus what? 1. Set each one equal to 0 and solve it. X equals 0, x squared equals 1, x equals plus or minus 1. Is the 0 between minus 2 and 2? Yes. Is the minus 1 between minus 2 and 2? Yes. Is the plus 1 between minus 2 and 2? Yes. There are three values where the derivative is 0. You have 3 min-max points. This is one, this is another one, there's a third one. The derivative is 0, that means you have horizontal slope. The derivative is the slope of the tangent line. If the line is horizontal, that means the derivative is 0. So that's how we prove Rolle's theorem. We check to make sure the criteria are good. If they are good, we take the derivative, set it equal to 0, solve it for x, see if the numbers land between the two numbers they've given us. The other theorem I'm going to look at is called the mean value theorem. Another 5 minutes, and we out. Again, the criteria for the mean value theorem, f of x has to be continuous. The function has to be continuous from a to b. The derivative must exist on the interval from open interval from a to b. And notice it doesn't say f of a has to equal to f of b here. That's a different rule here, different theorem. There's no mention of f of a has to equal f of b. It doesn't actually have to be. It could be, but it doesn't have to be. It says there must be. If you can satisfy these two conditions, there must be. It could be more than one. At least one value, we'll call it C, between a and b, or in the interval a and b, where the derivative at C will equal to f of b minus f of a divided by b minus a. That's the mean value theorem, the average. Graphically, by the way, what we're looking for, just in case you're wondering, what is that telling us? I use that when I teach electronics, engineering, or physics. Sometimes you have a force, like baseball. When the pitcher throws the ball and the hitter hits it, first there's no contact till it hits a certain spot on the bat. Then the bat starts to bend backward, or the ball will bend, or the golf, the same thing. So, for example, if this is the ball, this is the bat, the ball hits, you see the bat bends a little bit, and that's when you have the maximum force. Then it goes forward, and the ball starts to leave. So right there, when the ball is going toward the bat, this is the maximum actually amount. This one starts to leave the bat. If you want to calculate the area of that, what are we looking for? Is somewhere in between. It's called an average value, mean value. I'm looking for a height that I can use, that if I take the length times the height, this area, that'll be the same value as the blue one. That's really what I'm doing physically. And what this one says, you know what? The derivative of that has to equal f of b minus f of a over b minus a. So let's see what will happen. Let's take an example. Again, the difference between this and the other one, the third condition does not have to be true. F of a does not have to equal f of b. If it does, fine. If it doesn't, still fine here. So here's an example. f of x equals 5 minus 4 over x. 5 minus 4 over x. Now we got a problem till I give you the interval. The interval from where to where on this one? From 1 to 4. Because initially when you look at it, we got a problem. F of x is not continuous where? At 0. I don't care about 0. It's outside my interval. So inside that interval, I'm fine. So is f of x continuous? F of x is continuous from 1 to 4. Step number 2, we must have a derivative between 1 and 4. Let's take the derivative. And if you're thinking about the quotient rule, you can waste of time here. Because you can write that as what? 5 minus 4x to what power? Negative 1. What's the derivative now? The derivative of 5, which is 0. What's negative 4 times a minus 1? Positive 4x to what power? Negative 2. That's 4 over x squared. You could have done the quotient rule. There is no need for it. Now notice the derivative here exists except for what? 0. But again, my limit is outside that. So f prime of x exists from 1 to 4. So condition 1 is good. Condition 2 is good. The book says there must be a value c where f prime of that value equals f of b minus f of a over b minus a. So let's find the answer to this and see what the derivative is. This has to be a value c where the derivative of that value equals to that, between the 1 and the 4. I show you that between the 1 and 4, where the derivative of that is equal to that number. Well, let's see what that number is equal to. What is this equal to? F of b. b here is what? 4. So what's f of 4 minus f of 1 over 4 minus 1? F of 4, that's 5 minus 1, which is what? 4 minus. What's f of 1? 5 minus the 4, that's a 1. Now let's take our derivative and set it equal to 1. So 4 over x squared equals to 1. 4 equals x squared. X equals plus or minus 2. Since I'm only interested between the 1 and the 4, x will have to be 2. So there's a value between the 1 and the 4, which is the 2, where the derivative is equal to 1. And that does fit that criteria. So we just proved the mean value theorem. There has to be a value between 1 and 4 where the derivative is equal to 1. And the answer, yes, there is the 2 where the derivative is equal to 1. And that's between 1 and 4. Sometimes you see that equation written a little bit different, by the way. You look at this and they cross multiply it. You know? So it might look different in the book there. That'll be my last statement to mention. If you cross multiply, you are ready to leave, huh? It will look like this. So it might look like that equation. Just keep that in mind.